So thank you for watching this video. This is for actual exam P1 for sample problem 121 to 130. So for problem 121, it says we have joined the density function. Okay. Then what do you want to find? Find expected these things. Expected age. So what is the expected age? What is the expected this age of those things? So let's say, so here x are just the, so x is just the age, right? X is age. So this is just the find is x. Okay. So find x, we can use double integration or single integration. We can say like we use double integration. We can use this. Okay. So here, according to the x just equal, say range x is 2 from 2 to 10. 2 to 10. Y from 0 to 1. So the integration region is this, so this d. So we say this just like d. The x just equal d. Then x. Then this density function, right? X, y, dx, dy. So we can regard this double integration. Also, we can find this density function for x first, right? So we can use one variable integration, just single integration. So this density function about x is equal this, right? fxy. Well, okay. So this is for this x, for here x equal x. We just added those y. So this is dy. So y from 0 to 1. Okay, and maybe we need to multiply this, multiply k, or make this is just the density function, right? So let's say, so that's equal from 0 to 1, so 64. Okay, so 0 to 1, 10 minus xy squared dy. So this equal, so we just say we forget this constant. So this equal like first one, so let's say k. This is just the, okay, we the integrate out the 10, this is just a 10, right? So 10 minus y squared dy. So okay. So what is this k? K is make this is a density function. So this k is like we want to make sure. Okay, so make sure this is density function. So then x equal just this x. So x times 10 minus 1 over 3x dx. So x from 2 to 10. Okay. Okay. So we found that this k is just 1 over 64. Yeah. Okay. And so this is just we have two ways to find those x, right? First one is just regard this two double integration. Second one we just changing to single integration. So the result should be same. So if we from here, let's say double integration. we say the x from 2 to 10 dx, right? Then once we have x, y is from 0 to 1, the dy. So here, so fx 1 over 64, so 10 minus xy square, right? 10 minus xy square dy. So here dy. So here is about x. So here we have x. Okay. So just this integration, right? So this is this equal. Let's say we put a constant outside. So that's 64. I'm sorry, 64. So x 2 to 10. So here x. So here integrate out. So 10 integrate out 10 x. So here y square is 1 over 3. So dx. Okay. So for this integration, we just split into two parts, right? So let's finish. Okay. So 1 over 64. So here 10x dx. So minus, we just split into two parts, right? X squared dx. So now we can easily integrate out to get the result. So for problem 122, it says we want to calculate the expected time at which the device fails. So what is this variable? What is the time at which the device fails? So let's check when the device fails. Okay. So it says the device fails when and only when the second circuit fails. Second is for y. So this is just we want to find ey. Okay. So to find ey, we also have the two ways. Right. First one, we can regard this is double integration. Ey with ey just equals this, right? Ey equals this integration region. So y f x y dx dy. Okay. So this is a double integration. So the range for x y is this. So x y. So here x less than y. So let's say x equal y. So x equal y. So where is x less than y or y larger than x? We find this part. Okay. So just d equals this. This is d. So we can say this integration so equal. So we can determine x from 0 to infinity. X dx. Then once we determine x, so for y, so y, okay, this x, so y is from this y is x to infinity. So dy. So here y, we just plug in here y. So if x y 6 is negative x is negative 2y dy. So for this integration, so we involve those exponential functions integration. So this is one way. So we So we find the other way is we use we change this as like one variable, ey. So ey, so we need to find the density function for y. Okay, so y. So density function for y is like for giving x. So what is if y? Just giving x, we just add this apply. So this equal just the. So for giving x, oh no, for density function for y. Oh, for y is don't got confused. Y is for this y, so we just add all those x's, right? So if y equal, so this is y equal y, so x from 0 to y, for giving y, so x is, so f x y dx. Okay, so this equal, so 6 negative x negative 2y dx. Okay, so we find this equal 6 negative 2y. So this x integrated out is 1 minus ey, 1 minus negative y. Okay. Okay, so for this one, so we need to find it's, let's say we want to find, so this density function, so maybe the question is this coefficient, this is the density function for y, or this coefficient maybe we need to changing a little bit, or we can keep this. Okay, so let's say, so this is I think this is okay, so this equals 6 negative 2y minus 6 negative 3y. Okay, so ey equal, so just like, okay, y is negative 2y dy, so 6, so y from 0 to infinity, so minus this 6y is negative 3y dy. So for this integration, we need a double integration. So this double integration just take too much time. So for this exponential distribution, we need to know this. So let's say density function is lambda is negative lambda x, right? Density function. So for this exponential distribution, we have this x equal 1 over lambda, right? So what is x? X is this x lambda is negative lambda x dx. So this integration is 1 over lambda. Okay, so now we regard this as a formula. So we don't need to use double integration. So here, so apply to here, we can see, so here we come to here. Okay, so this is we just put the okay. So lambda lambda is 2. So here is negative 2y. So 2. So we have this so this equals 3 times 2y is negative 2y, right? So this is 1 over 2. Okay. And for this one, negative 3y, so we know let lambda equals 3. So 3y is negative 3y is 1 over 3. So this is 2 1 over 3. Okay, so we know this equal 3 over 2 minus 2 over 3. So this, I'm sorry, 3. So this equal 5 over 6. Okay. So here for exponential distribution, we didn't remember those things. Okay. Mean is this, and variance is 1 over lambda square. Okay. So for this problem, we have n can be 0, can be 1. So n can be 0, can be 1, can be so larger than 1. So we say n can be 0, can be 1, and can be larger than 1, and their probability is 1 over 2, 1 over 3, 1 over 6. So this n is number of claim. Okay, so if n equal 0, then no claim. Then n equal 1, they have claim. So claim size, this is claim size is if n equal 1, this is follow this exponential distribution. The mean is 5. So here we say lambda is 1 over lambda, mean is 5. So for n larger than 1, so this is, so here is total. We just put the total. So this is for this exponential distribution 1 or lambda is 8. So mean is 8. So we want to find these things. So what is this is between 4 and 8? So we have two cases. This case or this case, right? So we have two cases. So this probability is actually we have two cases. We equal. So we put this probability P. Okay. This probability P is when n equal 1. So this is n equal 1 is 1 over 3 plus this probability when n larger than 1. So larger than 1 is 1 over 6. So here is conditional probability. Yeah. So for this one, this actually is this probability, right? A is larger than A, larger than 4, less than A. So when A follow this exponential distribution. So we know there's a probability exponential distribution. So remember, okay, is equal. So between this 4 and A is equal E negative lambda. Lambda is 1 over 5, right? Yeah. So multiply 4. So minus E negative 1 over lambda multiply 8. Okay. So this part is just like that, 1 over 6. So this is between 4 and 8. So this is follow this exponential distribution. Lambda is 1 over 8. So we know just E 1 over 8, negative 1 over 8 multiply 4 minus E negative 1 over a multiply 8. Okay, right? So we can simplify this. So this is just so e like a negative point a minus e negative a over 5, or just a over 5. So use calculate, right? So plus 1 over 6, so that's negative 4 over 5.5. So minus negative 1. Okay. So for this problem, 124, we want to find the variance of y, giving that thus. So here our conditions x is larger than 3, y larger than 3. Okay, so here suppose x equals 3, y equals 3. So here 3, x equals 3, y equals 3. So we want to find the variance of y for this part. So this density function, so we say just adjust the line. So we can say there's a density function. Density function actually just some number k times negative x minus 2y. So this case make all integration equal 1. Okay. So what is density function for y? So density function for y. So this is just for each x, for each like y equals, so this x just add those x up, right? So this equal just another negative 2y dx, right? So integrated out. So here x integrated out is negative x, is negative 2y is constant, saying this is just constant. So this is just equal some constant is negative 2y. Okay, so this is the density function. So we know this is just the exponential function. So we can say this for y under this conditional distribution, this y should follow this exponential distribution for lambda is just lambda equal 2, right? Okay, so we say this variance of the exponential distribution 1 over lambda squared. So we can say equal 1 over 4. Okay, so here actually we don't need to calculate what is the case. We just make sure we just say like a k, like make this is a distribution, right? So because this is negative 2y, we know this k should be 2. Okay. So for problem 125, we want to find conditional density of x. Okay, so conditional density, we say density is just a probability, just like a conditional probability. So this joint density, we have, let's say we have this formula, like a and b, probability for a and b equal pa, then like this, we have this, right? So we can regard this joint density function is just a p a and b. So we have this formula, joint density function x y equal, so this is just the marginal density function. So here marginal density function is 2x. Okay, and so this is when x is fixed, then this is uh, margin. This is conditional density function for y. So we know this distribution for y giving x is uniform. Okay, so we know uniform from 0 to x, from 0 to x. Then the density function 1 over x. Right? So joint density function is constant. Okay. Okay. So then we can find the conditional density. So condition for giving y equal y. So we can do this way. Let's say the range for x and y is, let's say x is from 0 to 1. Okay, so here's 0 to 1. This is y. Okay, from 0 to 1. Okay, so we say that here giving y, giving x, the y distribution for y is uniform on the interval from 0 to x. So if we have this giving x equal x, then y is from this x 0 to x. Okay, so we know the range for this x or y is just this triangle, right? Yeah. Okay. So this is 1, 0, 1. Okay. So we can find the conditional density function of y giving y equal y. So y equal y is like this line, like this, y equal y. So this is just the density function, just add those x out. Okay, so we say this density function of y is just equals this, equals so this joint density function is 2, right? And then dx. So where x, the range for x is from this x, y to this x 1. So from y to 1. Okay. Okay. And okay. Oh, no. Says this is O is this. Like let's say O is the probability from this is this, right? 2, so 1 minus y. So this is all probabilities. Y is constant. Okay, then this is actually total. Yeah, this is total. So don't got confused here, a little bit confusing things. Okay, so those probability, density function probability, or probability is just 2, right? But just make sure this probability is 2, or the like not the probability, just the joint density function is 2. So just all is 2, but we make sure this is in all integrations 1. So we just divide by this constant. Okay, so this is this is a density function for density function of x. Yeah, so x. Okay, the conditional density function for x giving y equal y. Yeah, so this y is constant. Yeah, so x can change from this x to this x, right? So we find this x. Okay, so this y is constant. Yeah, so x, we say from 1 to y. Okay, so here this problem a little bit confusing, like find the conditional density function of y giving y equal y. Giving y equal y, it means we let the y fixed. So that x continue from here to here, right? Continue from y, continue from this y to 1. So we know this distribution for x is uniform. So just a constant. So we just make sure all constant, like make sure this is distribution is 1, right? Or all total probability is 1. So just that we know this is a uniform distribution from y to 1. So we know this density function. Actually, we don't need to change, just don't need to do those calculations. We can understand this, right? So density function is 1 over 1 minus 1, y. Okay, so 126, it is become probability problem. So this we just go back. Let's just start again. So basic probability. Okay. So here we have this probability, like let's say this n can be 0, 1, 2, 3, 4. So we just find those probability. So we have some conditions. Okay. So that we say the difference. So here between this difference is same. Okay. So suppose like okay. So if we find this one, so we can find all others. So let's say if this p, okay, first one is p, then p minus d, like p minus 2d, like that. Okay, p minus 3d, p minus 4. So okay, so we need to find p and d. So p is probability for n equals 0. Okay, so we want to find p and d. So how can find p and d? So we use this condition. So this is exact 40% by fusing 2 coulombs during a given year. So fusing 2. So this means this probability n equals 0, n equal 1. This is equal 40%. So this probability is just p plus p minus d. So 2p minus d is 0.4. Okay, so this is one condition. So we need to find other condition. So other condition is all probabilities equal 1. Right? So all probabilities equal 1. So we have like all probabilities 5p minus, so let's say d 2d, so minus how many d? So here's d 1d, 2d, 3d, 4d. Add them up is 10, right? Yeah, so minus 10d. So this equal 1. So we can find p and d. So let's say we need to find, we have these 2 equations, like 2p plus minus d equal 0.4. And 5p minus 10d equal 1. So we can find p, we can find d. Okay, then we can find everything. So let's say what we want to find is calculate the probability that the policyholder will find more than 3 claims. So we just need to find more than 3 is p minus 40. More than 3 is just equal 4. Okay, so n equal 4, right? We just need to find this. Okay. So this problem 127, it says 1.27 is we want to find the probability for total payout on 200 reported loss. So we know this will be centrally limit salient problem. Okay, because so let's say that this is centrally limit salient problem. Okay. So what we need is to let's say like pay, like we say like pay out P1, so we just pay as X. Okay, X. So X1 we want to find X1 plus X2 plus X200. This is the total. So this we want to find there's T between these two numbers. So this T follow normal, right? So we need to find, we use the formula, this T follow this normal. So N 200 mu and variance 200 N sigma square, take a square root. Okay. So at the first we need to find mu. So what is mu? So mu is the payout is, let's check. Okay. So the loss is uniform distributed from 0 to 2,000. And they have deductible 5,000. Okay. So pay here is 0. Here is we just say L minus 500 or 5,000, right? So there's a pay. So for this we need to find its mean, find its sigma square. So mean mu equal, so here's pay 0. So if L from 0 to 5,000, so this is 0. Plus, so from 5,000 to this is pay is L minus 5,000. Okay, and then this density function is uniform. So this density function is this. So dl. So for this integration, we use substitution. So let this equal L minus 5,000 equal T. So T equals 0 to this. Right? And so then T dt. So this equal half. Half. This and to this, and this is square. Okay. So okay, so this one we calculate. Let's say find this equal 5,625. Then find variance. So we need to find like so the payment is variance find let's check this square like payment pay this payment square. Okay, so this equal so here's 0 forget, saying this becomes this squared, so we need to do this integration, right? From here the payment is this, and so this thing is square thing. So this integrated out use substitution is 1 over 3. This is 3, right? So this 3 is 150,003. So divided by so here the denominator this. Okay. So then this p square minus mu square. So we find variance. Sorry. So here we can find variance is variance. We just put this as x. Yeah, variance equal this. Okay, this is some calculation. Okay, so then there's a total will follow this. Okay, so plug it in here. So we can find, let's see. So, so total we find this. So this become okay. Okay, so there's a t between this and this. So this just regarded like okay, this between A and B, right? So we just changing this to standard normal. So this is like a z between this like b minus mu over sigma, a minus mu over sigma. Okay, so we find this equal z less than, this is just some calculation, yeah. So, and negative 1.78. Okay, so now we check the table, normal table. We can find this probability. So this is just like 82. Okay. Okay. So this problem, we have 3 insurance: the auto, homeowner, and renter. So here just the 3 factor. So we use Venn diagram. Okay. Okay. So we say those 2 are mutually exclusive. So home and rent. So we just put okay, home here. Suppose it is home, and here is rent. Okay, so they are mutually exclusive. Okay, so the other one have some overlap. So this is for home, and no. This is for auto. I'm sorry. This is for auto. We put it as A. Okay, and then outside. So we just use this Venn diagram. Okay, so put those information, giving information to this Venn diagram. So let's say where we can put. So check it. Okay, 17% have none of those. So outside is 17. Okay, 64 have auto. So auto is 64, but 64 we have 3 parts, so we cannot put it as 64. So let's go back. So here, check the last one, 11. So check this, 11 have homeowner insurance. Have homeowner insurance, but no, not auto. So we know this is 11. This is part 11. Okay. And let's say, so this one, 35% have two of this. Okay, so we know those are two, those are 35% of this. So, and this is 64. So we know, so they, okay, so we find this is 35. And we know this auto is 64. So then we find this is 29. So we put 29 here. Okay. So we still have three parts we cannot determine. So we put this as x. Okay. Here as y. Here as z. So we need to solve for those x, y, z. So let's say, how can we solve? At the first we say x plus y equals 35, right? And also the total is 100. So we find x plus y plus z equal, so 100 minus all others, let's say minus 17, minus 29, minus 11. So we find this equal 43. Okay. So and other questions, other conditions, condition 3, twice as many of clients have home own insurance as have rent. So home is twice of rent. So homes 11 plus x, 11 plus x equal 2 of z plus y. Okay. So here we need to solve for this equation. So from first equation, second equation, we need really quickly we can find z. Then we can go back to find x and y. Okay, so we can find x, y, and z. So now let's say what is we want to find. We want to find have both auto and length. Both auto and length is just find y. So we find y equal what? Right? So this become algebra problem. So we find y equal 10. Okay. Okay, so this problem think this f(x) cumulative functions actually should be this equal 1 minus, okay, negative x of 100. So this means this x actually part of here. This x actually follow exponential distribution with lambda. So lambda equal 1 over 100, right? Okay. So this x from 0 to infinity. Okay. And so this is loss. Yeah. And the deductible have deductible 20. Deductible is 20. And the insurance reimbursement policy is between 20 and 120, you have 100% reimburse. And above 120, it says only half, right? So we found that, let's say G is a cumulative distribution function of the giving. Okay, so giving that the reimburse is positive. So there's a conditional, like a conditional. So here, let's say this is probability, right? This is, let's say G115 is there's probability, like this things like the inverse less than 115, but this is giving that the conditional, giving that the reimbursement is positive. So when there's positive is this, when there's x larger than 20, right? Okay. So let's check when the reimburse equal 150. Let's find this cut point for 115. We want to find this when r equal 115. So when here, when x equal 120, reimburse is 100, right? So 115 should be, and so should be more than 120. Okay, so here's 100, then plus 15. So 15, so here should be 30, right? Yeah, so here because this is from here pay half, so 30 more. So like here 30 so become 150. So here from 120, 150, 30, but they pay half, 15. So there's a problem. So we found this equal x equal 150. Okay. So now the problem becomes easy. This one is just such a probability, right? X less than 150, and when x larger than 20. Okay. So this probability is px larger than 20, and here x between 150 and 20. So now we want to find the probability. So we need to use the integration to find the probability, but this is the exponential distribution. So we should remember this, like this p larger than 20 is just e negative lambda times 20. Okay, and between 20 to 150 is e negative lambda times 20 minus e negative lambda times 150. Okay, so this is just equal 1 minus, we say this equal e this minus e this, e negative lambda. So 150, like 150, 20, 130. Okay. So what is lambda? Lambda is, let's say, 100, right? 1 over 100. So this is just equal 1.3. 130 over 100, 1.3. Okay. Okay, so for this 130, we have this normally generating function. So we want to find expected value for those things, expected value of this equivalent. So what is this value? So the value of piece of equivalent is this. So this we can say, this we can regard y is this, y equal 100, 0.5 x. Okay, so x has this density function, mobility general function. So we want to find ey. So ey equal thus 0.5x. This is right. So this we can take 100 out. So this. Okay. So for this x, we know it's mobility general function. So what is the mobility general function for x? Mobility general function is thus tx. So this one we know equal 1 minus 2t. Okay, right? 1 minus 2t. Yeah. Okay. So by now we know this, but we want to find 0.5x. So we just changing 0.5x to in this term. So 0.5x. So what is 0.5? So we can change this. Let's say we can change 0.5 as some power ln 0.5. Right? Okay. So 0.5x equal ln log 0.5x. Okay, so y become this becomes, so we plug it in. Okay, so equal log 0.5x. Okay, so we say this just equal mt when t equal log 0.5. Okay, so this equal 1 minus 2 log 0.5. So use calculate, we can find this. Okay, so we can stop here. This is so from 121 to 130, right? Okay, so we can stop here. So see you next video.